Hello friends, I'm Dr. Gaurav. In this video, I will discuss about second law of thermodynamics and perpetual motion machine of second kind. Contents are second law of thermodynamics based on Kelvin-Planck and Clausius statement, perpetual motion machine of second kind, equivalence of Kelvin-Planck and Clausius statement. Second law of thermodynamics. There are two classical statements of the second law of thermodynamics. First is Kelvin-Planck statement related to heat engines. Second is Clausius statement related to refrigerators and heat pumps. Kelvin-Planck statement. It is given by Lord Kelvin and Max Planck. According to this statement, it is impossible to construct a device that operates on a cycle to receive heat from a single reservoir and do an equivalent amount of work. You can see figure A. In this figure A, we are having a heat engine and we are supplying Q1 amount of heat from source at temperature T1 to this heat engine. Because of this heat, this engine is doing work W equal to Q1. So there is no sink in this figure A. So such type of heat engine is not possible because whatever amount of heat is supplied, it is doing equivalent amount of work. Figure B, in figure B, again Q1 is the amount of heat supplied from source at temperature T1 to the heat engine. Because of this heat supplied, this heat engine will do some work equal to W having a value of Q1 minus Q2, where Q2 is the amount of heat rejected to the sink at temperature T2. Such type of heat engine is possible. This statement can also be expressed as no heat engine can have a thermal efficiency of 100%. Next is Clausius statement. It is given by Rudolf Julius Emmanuel Clausius, a German physicist in 1850. According to this statement, it is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a low temperature body to a high temperature body. You can see the figure A. In this figure A, R represents the refrigerator. Now this refrigerator is extracting Q2 amount of heat from a low temperature body at T2 temperature and it is supplying or rejecting Q1 amount of heat equal to Q2 to the high temperature body at temperature T1. Such type of refrigerator is not possible because we cannot supply heat from a low temperature body to a high temperature body. Second figure, in this again we are having a refrigerator which is extracting Q2 amount of heat from a low temperature body at T2 because we are supplying W amount of work to the refrigerator. Because of this work, it is rejecting Q1 amount of heat equal to Q2 plus W to the high temperature body at temperature T1. Such type of refrigerator is possible because in this we are supplying heat from low temperature body to high temperature body, and this is possible only when we will supply some input work. Like any other physical law, this second law of thermodynamics is based on experimental observations. To date, no experiment has been conducted that contradicts the second law, and this should be taken as sufficient proof of its validity. Next is perpetual motion machine of second kind, a device that violates The second law of thermodynamics is known as perpetual motion machine of second kind. Perpetual motion machine of second kind follow first law of thermodynamics as it violates Kelvin-Planck statement as shown in figure A. In figure A, we are having a heat engine in which Q1 is the amount of heat supplied from source at temperature T1. Because of this heat supplied, this heat engine is doing work W equal to Q1. So, whatever amount of heat supplied is converted into equivalent amount of work. So, we are having 100% efficiency. Such type of heat engine is not possible, and such type of heat engine is an example of perpetual motion machine of second kind. Figure B, we are having refrigerator. In this refrigerator, we are extracting Q2 amount of heat from a low temperature body, and we are supplying Q1 amount of heat equal to Q2 to the high temperature body. So, in this figure B, we are extracting a heat from low temperature body and supplying heat to the high temperature body without any work input. So such type of refrigerator is not possible, and it violates the Clausius statement. But it is an example of perpetual motion machine of second kind. Third is heat pump. Again we are extracting Q2 amount of heat from a low temperature body at T2, and because of this heat pump we are supplying Q1 amount of heat equal to Q2 to the high temperature body at T1. Again we are not supplying any input, but we are transferring heat from a low temperature body to high temperature body. So this is not practical possible. Again this such type of heat pump violates the Clausius statement, and such type of heat pumps are not possible. Figure A, in this we have heat engine. Such type of heat engine violates the Kelvin-Planck statement. So, perpetual motion machine of second kind does not exist. Next is equivalence of Kelvin-Planck and Clausius statement. Second law basically a negative statement like most laws in the society. The two statements, that is Kelvin-Planck and Clausius statement, look distinct. We shall prove that violation of one makes the other statement violation too. Violation of Kelvin-Planck statement leading to the violation of Clausius statement. A heat engine that operates from a high temperature reservoir at temperature TH and receive QH amount of heat from this reservoir and convert it to completely into an equivalent amount of work equal to QH without rejecting any heat to the low temperature reservoir TL. This is the violation of Kelvin-Planck statement. So here we are having a heat engine in which we are supplying QH amount of heat from a high temperature reservoir at temperature TH, and this is doing an equivalent amount of work W equal to QH. So that means this heat engine will have 100% efficiency, and such type of heat engine violates the Kelvin-Planck statement. Along with this, the refrigerator which extract QL amount of heat from low temperature reservoir. So this is the refrigerator. It is extracting QL amount of heat from low temperature reservoir at temperature TL. Is supplied with QH amount of work from external agency and supplies QH plus QL units of heat to the high temperature reservoir at TH. So we are supplying W amount of work having a value of QH to the refrigerator. So it will supply QH plus QL amount of heat to the high temperature reservoir at temperature TH. The work and heat interaction for the heat engine and refrigerator when coupled together. So we have combine these two, heat engine and refrigerator system. The output of the engine is utilized to drive the refrigerator. So output of this engine is utilized to drive this refrigerator. So this QH amount of work obtained from the engine is supplied to the refrigerator in the composite system. This composite system continues a device which transfer heat QL from the low temperature reservoir at TL to a high temperature reservoir at TH without any work input. So when we combine these two, then the net value of work will be 0, and this composite system is extracting QL amount of heat from the low temperature reservoir and supplying QL amount of heat to the high temperature reservoir at temperature TH. Such type of composite system is violation of Clausius statement. So we are supplying heat from a low temperature body to a high temperature body without any type of work input. So this is the violation of Clausius statement. That means at the starting we have assumed violation of Kelvin-Planck statement, and this leads to violation of Clausius statement. Thus we can say violation of Kelvin-Planck statement leads to the violation of Clausius statement. Next is violation of Clausius statement leading to the violation of Kelvin-Planck statement. As shown in figure, a refrigerator R transfer QL amount of heat from a low temperature reservoir at TL. So this is the amount of heat extracted from the low temperature reservoir at TL to a high temperature reservoir at TH without any work input. So value of W is 0. So this refrigerator is extracting QL amount of heat from low temperature reservoir and transferring this heat to the high temperature reservoir. This is in violation of Clausius statement. You can see this is in violation of Clausius statement, as we are transferring heat from a low temperature body to a high temperature body without any work input. Along with it, we are having a heat engine takes QH amount of heat from a high temperature reservoir at TH. So this is the heat engine. It is supplied with QH amount of heat from high temperature reservoir at TH. Delivers QH minus QL amount of work to the surrounding. So this is supplying, or this is or we are having output equal to W having value QH minus QL to the surrounding, and rejects the remaining QL amount of heat to the low temperature reservoir at TL. So it is rejecting QL amount of heat to the low temperature reservoir at TL. The heat interaction and work for the refrigerator and heat engine when coupled together, this composite system constitutes a device that receives QH minus QL amount of heat from a high temperature reservoir at temperature TH. So when we combine these two, refrigerator and heat engine, then you can see the arrow of QL is upward and the arrow of QH is downward. So the net value of heat will be QH minus QL for the composite system. That receives QH minus QL amount of heat from high temperature reservoir TH and convert it completely to an equivalent amount of work equal to QH minus QL without ejecting any heat to the low temperature reservoir at TL. So you can see here the arrow of QL is upward, and in case of engine the arrow of QL is downward, so it will be cancelled out. So, and if you add these work, you will get W equal to QH minus QL. So heat ejected to the low temperature reservoir is 0. So in such type of system, we are supplying QH minus QL amount of heat to the composite system, and it is doing work equal to, it is giving work equal to QH minus QL. So what we can say, amount of heat supplied, it is utilized to perform an equivalent amount of work. So such system will have thermal efficiency of 100%, and such system violates the Kelvin-Planck statement. So at the starting we have assumed that there is a violation of Clausius statement, and at the end we found that there is a violation of Kelvin-Planck statement. Thus violation of Clausius statement leads to the violation of Kelvin-Planck statement. Thanks. Any questions you can write to me gaurav.citem@gmail.com.